Hello, I am Dr. K. Misra from our classes. In the series of presenting topics of operations research, today I am going to talk about sequencing. Let me tell you, prior to it, I have completed CPM per LPP, wherein simplex method, graphical method, transportation problem, assignments problems, traveling salesman's problems. Now we are going to do sequencing. The topics which I would be covering here: what is sequencing, objective of sequencing, types of sequencing problems, assumptions, methods of solving sequencing problems, algorithm for solving sequencing problems, n jobs 2 machines, n jobs 3 machines, n jobs k machines. Now what is sequencing? Sequencing problems arise when we are concerned with situations where there is a choice as to the order in which a number of tasks can be performed. In such cases, the effectiveness is a function of the order or sequence in which tasks are performed. A sequencing problem could involve jobs in manufacturing plant, aircraft waiting for landing and clearance, maintenance scheduling in a factory, programs to be run on a computer center, customers in a bank, and so forth. It is basically the selection of an appropriate order in which a number of jobs, means operations, can be assigned to a finite number of service facilities, say machines or equipments, so as to optimize the outputs in terms of time, cost, or profit. Here, we shall consider the sequencing problems in respect of the jobs to be performed in a factory and study the method of the solution. Such sequencing problems can be broadly divided into two groups. In the first one, there are n jobs to be done, each of which requires processing on some or all of the k different machines. We can determine the effectiveness of each of the sequences that are technologically feasible and choose a sequence which optimizes the effectiveness. For illustrating the timings of processing of each of the n jobs on each of the k machines in a certain given order may be given, and the time for performing the jobs may be the measure of the effectiveness. Here we shall select the sequences for which the total time taken in processing all the jobs on the machines would be minimum. And the second type, that is two jobs on k machines, that may be covered later. Objective of sequencing. The objective is to determine the sequence of jobs which will allow all jobs to be performed so that the time from the beginning of the first job till the completion of the job is the minimum. The answer to the sequencing problem would also indicate to the management information like which of the machine or machines would, if at all, be idle and for how long, whether the work on the jobs can be done in the given week without overtime, and if not, which jobs will need overtime work. Now, types of jobs. Here which I would be covering processing n jobs on 2 machines, processing n jobs on 3 machines, processing n jobs on k machines, and processing 2 jobs on k machines. There are certain assumptions that we must keep in mind. Say, first, the processing times on various machines are independent of the order in which different jobs are processed on the machines. The time taken by the different jobs in going from one machine to another is negligible. A job once started on a machine would be performed to the point of completion uninterrupted. A machine cannot process more than one job at a given time. A job would start on a machine as soon as the job and the machine on which it is to be processed are both free. So these are the assumptions that we must keep in mind while optimizing the different jobs on different machines while determining the sequences. Now, methods for solving sequencing problems. Sequencing problems can be solved using the Gantt chart, for which practical problems would be discussed in the following video tutorial, and by applying an algorithm that is known as Johnson's rule. Algorithm for solving sequencing problem. Johnson's rule. First, processing n jobs through two machines. Steps only or the point sequence to be kept in mind. Only two machines are involved here. Each job is to be processed in the order AB. Let me tell you whether the machines are designated at A, B or M1, M2. The order is already fixed. This cannot be changed. So that the first work would be performed on machine A and then on machine B. The processing times for different jobs on first machine A1, A2, say for example AN, are given, and so are the processing times on this second machine B1, B2, etc. With the objective to determine the sequence in which the jobs may be performed so that the total time taken, basically total time taken is here known as elapsed time. Total elapsed time is the minimum. We proceed as follows. Let AI be the time required by job 1 on machine A, BI time required by job 1 on machine B, capital T total elapsed time for jobs 1, 2 to N, TI that is idle time on machine B from each of the job 1 I to 1 to start job 1. Now algorithm for sequencing problem, Johnson's rules here continued. The objective is to determine the sequence S in which the small n jobs may be performed so that the capital T, that is total elapsed time, is minimized. We know that the total elapsed time T is determined by the point of time at which the first job goes on machine A and the point of time on which the last job comes off machine B. At any moment of time, the machine B is either working or idle. The total time for which the machine B has to work is summation I is equal to 1 to NBI, which is determined by the given job times and has nothing to do with the sequence in which they are performed. Thus, it is said the total elapsed time actually is equal to summation I is equal to 1 to NBI plus summation I is equal to 1 to N small ti, where small ti is basically the total idle time. Now, rules to processing n jobs on two machines. In the operational terms, algorithm can be stated in a stepwise manner as follows. Number 1. Select the smallest processing time considering A1, A2, etc. and B1, B2 together. Number 2. A. If the minimum is for A, say for example Rth job, AR, that is to say for Rth job on machine A, and do the Rth job the first. B. If the minimum is for BS, that is for Sth job on machine B, do the Sth job in the end. In case of a tie between AR and BS, perform the Rth job first and Sth job in the last. If there is a tie between two or more timings in either of the series, select either of the jobs involved and perform the first or last accordingly, as the tie is in A1, A2, AN or B1, B2, BN, etc. Third, after the job or jobs has or have been assigned, apply step first and second to the reduced set of processing times obtained by deleting the machine times corresponding to the job already assigned. Fourth, continue in this manner until all the jobs are assigned. The sequence of jobs to be performed obtained in this way shall be optimal, involving the least aggregate time for completion of the jobs. Processing n jobs through three machines. As such, no general solution is available, except enumeration, of course. For the sequencing problems of n jobs through three machines, however, we do have a method applicable under the condition that no passing of jobs is permissible, that is the same order over which machine is maintained, and if either or both the following conditions are satisfied. For three machines A, B and C on which some jobs are to be performed in the order ABC, so the two conditions or either of the two conditions must be satisfied. Number one, the minimum of the times for different jobs on machine A is at least equal to the maximum of the times of different jobs on machine B. Number two, the minimum of the times of various jobs on machine C is at least equal to the maximum of the times of the different jobs on machine B. If minimum AI represents the least of the job times on machine A, minimum CI represents the least of the job times on machine C, and maximum BI indicates the largest of the job times on machine B, then if either minimum AI is greater than or equal to maximum BI or minimum CI is greater than or equal to maximum BI or both are satisfied, then the following method can be applied. Method of processing n jobs through three machines. Here, step first, replace the given problem with an equivalent problem involving n jobs and two fictitious machines, say for example G and H, and define the corresponding processing times Gi and Hi as follows, where Gi, that is Ai plus Bi, and Hi, that is Bi plus Ci. Thus for the job 1, G1 is equal to, for example, A1 plus B1, H1 is equal to B1 plus C1. For the job 2, G2 is equal to A2 plus B2, S2 is equal to B2 plus C2, and so on. Now step 2. To the problem obtained in step first, apply the method discussed for processing n jobs through two machines. The optimal sequence resulting from this shall also be optimal for the given problem. Now let us have a semantic presentation of the algorithm for processing n jobs through three machines ABC in the order ABC. Almost the same what discussed earlier. First step, start. Second, arrange the time for each job on different machines in a columnar form. Is minimum AI greater than or equal to maximum BI and or minimum CI greater than or equal to maximum BI? If no, no general solution is available. If yes, determine GI and HI as GI is equal to AI plus BI and HI is equal to BI plus CI. Select the smallest of the job of GI and HI considered together. Is it GI? If yes, perform the Rth job first and delete it. If no, is it HI? If yes, perform the Sth job the last and delete it. If no, for tie in, say first GR and HS, perform the Rth job first and Sth the last. Second, GIs select either of them to do first. HIs select either of them to do last. Delete the jobs assigned. are all jobs assigned? If yes, problem is solved. If no, stop. Processing n jobs on k machines. Like earlier, we discussed about 3 machines. For k machines also, except enumeration method, there is no other method available. But yes, we do have some pattern here wherein we can obtain optimal sequence or sequences in problems involving processing of n jobs on k machines by satisfying the following two conditions. Number 1, minimum AI is greater than or equal to maximum BI, maximum CI, etc. greater than or equal to maximum GI. That is, the minimum of the job times on machine A should be at least equal to the maximum of the job times on machine B, machine C, etc., machine J. Similarly, condition number 2, minimum KI is greater than or equal to maximum BI, maximum CI dot dot and maximum GI. The algorithm works as follows. Step first, obtain timings on two fictitious machines, say for example x and y, such that xi is equal to ai plus bi dot dot ji and yi is equal to bi plus ci dot dot ji plus ki. Step 2. Determine the optimal sequence of performance of the jobs on x and y in accordance with the rules given earlier in respect of processing n jobs on two machines. The resulting sequence shall be optimal for the given problem. Here, an example is taken as discussed for processing n jobs on two machines. So what we do is practically we take first the least time of a job involved on machine A1 or machine 2. If it is on machine 1, we keep it on extreme left, and if it is on machine 2, we keep it on extreme right. Say here, the least job is 1 for the job 3 on machine 1. So this is why 3 is sequenced at the very first extreme left. Now after 1 comes 2. So that is, and there is no another 1. So after 1, that is 2, and 2 again is for job 2. So this is why 2 is coming just after job 3. After 2 is 3, that is for job 1. Now you see here that it is being put on extreme right. So extreme jobs are 3 and 1. Now in between, accordingly they are performed on machines M1 or M2 will be put. As far as 4 and 5 are concerned, you see, accordingly they have also been put. So that's how you can understand. I will be taking up various practical problems and will be uploading videos on sequencing of different types. So for any queries, you can write to ourclasses@gmail.com. More video tutorials on quantitative techniques and operations research and on personality development also are available on my YouTube channel. You can click on this link. Thank you for watching. Please like, share and subscribe. Thank you. Have a nice time.